Alright folks, this is Shetz, and today we're going to prove that all the angles of a triangle add up to 180. We are allowed to draw a line through this outside point and this line. There's exactly one line parallel. So we're allowed to draw that. Draw, and I'll call this A, B, C, D, and E. So draw AB parallel with DE, and that's by the parallel postulate. There's exactly one line that's parallel to the bottom line going through that point C. Okay, so because we know these are parallel, and let me mark them by this postulate right here, we know that angle 2 is going to equal angle 5. And that is by alternating interior angles are congruent. We also know that 4 and 6 are going to be equal. And I'll put that on the same line. Angle 4 is congruent to angle 6. Great. Now, here's how we get all three of these equaling 180. I'm going to add these two together. So, measure of angle 5 plus the measure of angle 3 is going to equal the big angle, the measure of angle ACE. And if you notice, we're adding angles, so that's the angle addition postulate. And now I can take this big angle. Remember, angle addition postulate means two little angles add up to be the big angle. Great. Now I'm going to take the big angle, measure of angle ACE, and add that to measure of angle 6, and that equals 180. Why is that? Because it forms a linear pair. Or if you want, you could also say angle addition postulate. So here we go. So angle 5 is the same as 2, and angle 6 is the same as 4. So I'm going to put the measure of angle 4 there. And 5 and 3, well, instead of the 2, I'm going to put instead of the 5, I'm going to put a 2 there. Measure of angle 2, and here's my measure of angle 3. So there, we've proven this step right here, and that is because of double substitution. Double substitution. So there you go, folks. There's how we know that the angles of a triangle add up to 180. Thanks.